Alrighty. So today, let's look and see what. Did you miss a question on the test or what?
I did too.
All right. Well, I'll pull yours up.
You to go ahead and go over all the hard questions. Just and then, let me tell you why I want to do it. Let me tell you why. Something I've never done before is I want to pull up my Excel and I want to do it in Excel. I try to write things. I'm
that's why I said I watched this video. I did it in Excel while he was there. So
well, wait a minute. You did what?
I pulled up your video.
You watched my video. Wow, what a concept.
I'll leave now.
You know, no. Listen, you know what she did? She pulled up my video on something that she couldn't understand and watched it over and over again.
That's pretty handy.
Wow.
Did you take the last class and put it on there?
Yes.
All right, fine.
I will go over it for you, okay? But I'm going to pull up your test, okay?
My test? I mean, you don't want to pull my test though.
Well, I got to pull up the question that you had.
65.55%.
Hey, I got a question.
Okay, now that you told everybody, I'll go ahead and pull it up.
Oh, you gonna pull it up?
Yeah, I'm going to pull it up. All right, where are you?
Melanie Bradley, third
I'm
one
looking.
down on the left-hand side.
There it is. All right, there it is. Whatever.
I can't see shit.
Okay. Tell us how you really feel.
Right turn the lights on.
Well, listen, if you can't see, you need to go back to that right back corner back there.
Is that where it works?
Yeah, that's where it works best.
Somebody go tell this girl to get her homework done. I did not see that one. I got
What are you
right.
talking about? All right, what number?
I got 10 wrong also.
Well, I'll tell you what, let's look at number 9.
Well, I said 10.
Well, I'm going to go over both. I'm going to go over, she got number 9 wrong. I'm going to do number 10 for you, or you tell me what it looks like. All right, here is, the following data represents the number of people, blah, 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 blah. Find the mean and standard deviation. Well, the first thing you're going to do is send it over to the Excel spreadsheet unless you do it by hand. And that's fine if you do it by hand. But I'm on, for instructional purposes, I'm going to do it on the spreadsheet so y'all can all see it. Does not mean you have to do it on Excel. All right, there it is. And I will make it bigger and I'll turn the lights off. I hope I'm recording.
I don't think. Are you?
I think I
And
am.
then editing. Well, all the lights on.
Yes. I'll check to make sure I'm editing after I do this.
And what was it about Foxtrot 4, whatever? What do I have to do with that? What does that have to do with anything? Or do I have to start like laptop?
You only do it one time. That's when you're subtracting X bar from X. Yes, when you're doing data. When we do one, I'll show you.
Because you said on the video, I was like, I missed something.
Okay. I'm just so thrilled that somebody watched the video. I mean, honestly, okay, wow. 2 people.
Wait a minute.
Wow.
Number.
Wow, 3 people.
I don't watch them, but I will.
Okay, there's the one I was wanting to hear. That's the one I was trying. There we go.
34.
All right, there's that. And let me check to make sure that I'm recording. Just say. All right, there's the numbers. Now, before I start, I've got F. Here's F right here. Okay.
When you say 2, why did you put all those zeros when it's 39.7, 34.9, blah, blah, blah?
Did it do that?
Because that new test, it's millions.
Numbers.
Yeah.
Okay.
You can knock off the if you want to, but I'm just.
No, I want to do it just like you.
All right. Now, the first thing, you got F. So let's go ahead and mark that because that's good. That's good for day. But we don't have X. Why? Because we haven't calculated X yet. X is the what? Midpoint. And the only place we can get a midpoint is these classes. But I can't calculate 25 to 34. So what I'm going to do is I'm going to call it lower class limit and upper class limit. You don't have to do that. So this is 25, 35, 45, and 55. And this is 34, 44, 54, and 64. And now I've just fixed it to where I can calculate the what? The midpoint. And what is the midpoint? Equals, parentheses, 25 plus what? 34 divided by what? 2. And then copy that down. Now I have what I need. So what I'll do is I'll take my handy dandy highlighter and we'll highlight this yeller.
And that was 25 plus 34 divided by.
Yes, ma'am. Your lower class limit plus your upper class limit divided by 2. And that finds the midpoint. What the heck?
What?
Freaking bug on me.
Good.
What the heck?
You bring your pet to work today?
Some kind of beetle. Look at that.
God. God.
No. Where did it come from? Did you bring it in here? Here.
Show me one more time how you got however you did that witchcraft stuff.
Witchcraft.
Witchcraft.
There it is, right there. Parentheses. I took this guy plus this guy and divided by 2. And then I copied it down. Put the little cross right there. Hit the left button on your mouse and pull down. Okay, what else do I need for my formula?
You ever push F4?
No, not on this. This is
Just checking.
that's data clip. That's data when you got like 5 scores. We need N. And what is N? Summation of what? Summation of F.
Can you click on that?
So you just hit the auto sum?
Yeah.
Okay.
And that is going to be highlighted in aqua. So the 3 colors are the things that we need for our formula. And our formula, hold on just a second. Let me pull up my handy dandy. I don't know if I'm recording. Yeah, I am. I gotta pull this up so I can draw. So I'm waiting. There we go. Okay, and pull this back up. There we go. Our formula for our mean, our x bar, is equal to the summation of f times x over n. Okay? The summation of f times x over n. And the standard deviation is equal to what? Well, that's the big one. Well, variance. We got to do the variance. Because yeah. Huh?
Is that the one you raised to 0.5?
No, hold on just a second. Variance is equal to the n times the summation of f times x squared. I'll put that in parentheses. Minus the summation of f times x, what? Quantity squared over n times what? N minus 1. Now that's the variance, and as you just said, the standard deviation is equal to the square root of the what? Of the variance. So we got everything we need. We got our f, we got our x, we got our n. But we don't have what? We don't have x squared, and we don't have f times x, and we don't have f times x squared. So we need 2 more columns. So we take our handy dandy cursor, and I'm going to skip them so you can actually see. We're going to put, well, I'm going to put x squared right here. X squared. And that's going to equal this number to the second power. Copy that down. And I like to put it center because I don't like to have things off centered. Okay, why isn't it that centered? I took x and what I do to it? I squared it. So we'll color that orange color. We need, and we take our handy dandy highlighter, and our yellow is our x. So there's our x, and here's the x, and our x squared, orange, there's that. And then what else do we need in our formula? We need our green per day, and that's f, 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 and then our n is blue. I'm doing this for a reason. Okay, what have you noticed about all the colors? They're all taken up now. In other words, is there anything that doesn't have a color? No. So you've got everything you need to put the bicycle together now. All you got to do is read the what? Read the directions. So what does this direction say? Page 1 of your direction says take f and multiply by what? X. So I go over here and I make a column. I skip a space because I want to put it separate. These are the formulas. F times X. And I do what it says. F times X. And I copy it what? You have to put an equal sign. Okay, now, what does this say? After I get f times x, what do I need to do to it? I need to add it up, sum it up. And that's that number right here. So now I'm going to take my handy dandy highlighter and I'm going to highlight that like, ooh, that's rough. I want to make it a light purple. Okay. Now I take my handy dandy highlighter And we color it, don't have a purple. I have to do it magenta. And that is that. Okay, that's that color right there. So, things I do for y'all.
When you go back to the,
I'm picking a color right now, please. Let me pick my color. And after I pick my color, I'll answer your question. Okay, question.
when you go back to the F times X, when you put it in the Excel,
Right there.
the formula like this.
Equals C2 times D2.
No parentheses?
Don't need it because it's just an operation. The only time you need parentheses is when you have more than one operation. It's just like your calculator. Your calculator can't discern what to do first. Like in these problems, right here, in the midpoint, there's two operations. There's plus and there's division.
Gotcha.
If you put that into the calculator is going to take the first number plus the second number, and it might take the second number and divide it by 2 and add it to the first number. So you have to discern what to do. You have to tell it what to do. So that does not need, because it's just multiplication. That doesn't need it because it's just multiplication. Okay, so that is that number right there, and this number. Hey, we've got what we need to get the what? The mean. We've got the purple, and we've got the magenta, and we've got the blue. So
That's more like a baby.
okay, whatever. Let me change it for the critic. No, it's more of an
That's
aqua.
more of a baby.
Well, I'll have to do that. I'm sorry. All right, so here's our mean. Mean of this frequency distribution is equal to this number divided by this number. And there's your mean. Now let's find the variance. Let's read the directions. Let's see, f times x squared. Do we have an f times x squared? No. So what does that mean? We need to do it. So f times x squared. The reason I'm not coloring these colors is because that's not what you use in the formula. You use this in the formula, so that's why I'm not coloring these. All right? And that's equal to f times x squared, which is going to give you a BA number. And what do we need? Let's read the directions. What do we need with that? We need what? Summation. So we'll do that. And we'll color this guy. Hold on.
What are you doing?
Just changing it to where it doesn't use scientific notation. Because it may blow some people, their head may melt if I do that.
For sure.
And I don't want to do that. So we'll color this. Hang on. I'm running out of colors, so y'all just bear with me. Let's change it to a kind of a red color. Mauve. Okay. And that's now I'm doing the best I can with the colors. Y'all just bear with me.
Shadows real.
Huh?
Shadows real.
I know. So there's that. That's that color right there. Now what do we got to put in front of that? N. Well, I'll do all that down here. But do we have this number? Yes, we have this number. That's that number right there. We got that. we've got everything we need. So we go down here, and this is where I put everything, out there where you can look at it. So variance is equal to, and we'll follow the directions. I'm going to take n. I'm going to multiply it by f times x squared, which is this. And I'm going to minus. Now the reason I write out minus is because if I put a negative there, it's going to want me to put a formula in there. So I put minus. And then what? F times x. F times x is this number. Quantity what? Oops, sorry. Let me just redo that one. I messed that up. Oh, yeah. Quantity what? Over n, which is this, times this minus what? So the variance is equal to this number times this number which is a BA number minus this number raised to the second power. They could have done without making this into the millions.
Wow.
It would have made the problem a whole lot easier. Over this number, this number times this number. So the variance is equal to this number minus this number over this number. So the variance is equal to this BA number divided by this BA number. There's your variance. And the standard deviation is what? Is equal to this number raised to the 0.5 power. And that's your second number that you need. So we'll make this one bright green. They have a bright green. Oops, that's the wrong thing, Hubert. So that's the number you want. And this is the number you want. So 44.3 and 10.6. So let's see what the answer was. 44 point what?
8.
Oh, well, they got 44.3 also. And 10 point what? I got 10.6. Yes, 10.63. Okay? How you feel on that one?
So it's 44.82 for the answer?
44.82, 44.32, and 44.71.
Why is this such a variable?
Because you could have done it with a decimal, and if you do it with a decimal, the rounding is different. That's why. It's all about rounding. Okay, next problem. Now, you said you missed number 10. What kind of question was number 10? I don't know if it's the same one as this one. Is that it?
Yeah.
Okay. So, look at this one. It says that the person that can't do this problem should live in a ditch. That's what it says right up here. Suppose babies born after a gestation period of 32 to 35 weeks have a mean of 2,500 and a standard deviation of 6. When you see those two numbers, what do you do? When you see the mean and the standard deviation, what should kick in? I need to draw a picture. That's what you should be doing. Or you can sit there and quit.
Oh, yeah, no. Of course I answered nothing.
So I draw a picture. The mean is 2,500. And what do I do with the standard deviation? Add it
That's 600.
and subtract it. Now that's going to be 600, so that'd be 3,100 and 3,700. And minus 600 is going to be what? 1,900 and 1,300 and 1,300. And that takes care of this stuff. Okay. Now, it says that 40 weeks have a mean of 3,100. I think this is going to be a z-score. $3,100 and 440. And that's going to be 3,540. What's the next one? 39. I'm looking 440.
What are you adding?
Or
Sorry.
440. 440.
Yes.
I know it's 440.
So it'd be 3,540. 3,540, and what's the next one?
3980.
3,980. And subtract it, what do you get?
2660 and 2220.
2660. And what?
2220.
2220. And that takes care of this stuff. I have a feeling this is a z-score question. If a 33-week gestation period baby weighs 2,750 and a 40-week gestation weighs 3,350, yeah, find the corresponding z-scores. All right, so each of these, you can put a 0 here, and a 1 here, and a 2 here, a -1 here, and a -2 here, a 0 here, 1, 2, -1, -2. Now, that doesn't tell us anything. It tells us that we can take this baby at 2,750 and draw a 2,750 is where? Right in here? 2,750 would be halfway, about halfway, so that one's right there. And then 3,350 would be somewhere right in here. But that doesn't tell us anything. It tells us that this one is bigger and this one is, as far as but which one is relatively bigger? So you got to do a z-score for each one. So z-score for this guy is going to be 2750 minus what? 2500
That's the median.
over what? 600. Okay, please. Z for this guy is going to be 3350 minus 3100 over 440. All right, somebody do the first one. What's the z-score? I think it's around 0.5.
0.416.
0.42.
0.42.
0.42. All right, what's the z-score down here? 0.57. So which baby is relatively larger? It's 0.57.
40-week baby. 40-week. 57.
The 40-week baby. Okay, and that's what they're asking. The 33-week is 0.42 standard deviations above the mean. That's what your number means. And the second one is 0.57. Which one is larger? Because the baby born in 40 weeks is larger. Okay, so that's how you do that one. Can't believe I'm doing this for y'all.
I can't believe that one's that easy. That last one, I just gave up on that one, but that one.
That's what you're supposed to do. Give up. 10, and that was 10, now 11.
When you went to do that, I just.
Oh my gosh.
I know.
I stress it and stress it and stress it. Y'all don't listen to me. Let's talk about it. Determine whether it's qualitative data is discrete or continuous. The number, ding ding ding. The number. Is number a measurement or count? Violent crimes. That would be discrete because it's a number, not a measurement.
Would cholesterol levels be
Cholesterol is measured,
measured?
so it would be continuous.
That one that we did when you kind of did a review last class, and it said the answer was 0.35, and I mean 2.35 because I added the out,
Yeah.
I think it was, and the answer, it marked it wrong on the test for me and said that 0.3 or 2.3 or 2.5 was correct
Oh, I need to fix that for you.
because it was the way too I take
Yeah,
it.
that one's
Okay.
on here too. On this one, I got wrong.
Okay,
When I
well,
take it again now, I'll know. I just didn't.
y'all realize I'm a male, right? You're throwing 2 or 3 things to me at one time. You know, I
But
can't
you're a
do
parent
that.
also.
I can't do that. No, I'm not a parent. No, I'm a terrible parent. Okay, so that was number, what was that? I can't, 11. So next is number 13. The native languages of students, qualitative or quantitative?
That's qualitative. I just didn't answer it. You answered
You
mine.
gave up by
Well, my
then.
class was starting. I had to give up.
Oh, okay, it's my fault. Okay, 13, 14.
Cole got that one wrong too.
Hey. All right.
How do you know that?
Now,
What was the one I got, the
now we don't work
2.35?
This is it?
Almost.
This is what you're talking about?
Yeah.
Okay.
Same thing like we do for Z-scores, right?
Scores, wait a minute. Scores of an IQ test, can I read it first? Have a bell-shaped distribution with a mean of blah, blah, blah. The empirical rule, use the empirical rule. Yeah, this is the empirical rule. This is straight percentages. It should be.
Exactly, like in the book, and yes.
Well, let me see what I come up with, and then we'll talk
Like
about
I
it.
came up with it very close, but no guts.
I just got the last one wrong. I did a 2.35.
All right, this is 34. This is 34. This is 13.5.
How do you know that's 34? Because it's probably on the bill.
The empirical rule,
Just asking.
Because normally they put 68. They don't break it down like this. So look.
And the next one's 0.1.
2.5. That should be on page what?
It's on
138.
138.
Oh, I think I had that written.
Oh, you did? What was that in? Was that in your notes? Okay.
So the book says 2.35, not 2.5.
That's because some books say 2.5, some books say 2.35, and then the rest is 0.15, and 1.5 is the third standard deviation.
Yeah.
So that's probably why you have a,
So we want to make sure that we use this right here.
So-
See, that's why I got it wrong. 'cause I
well,
got
it's
that.
whatever's on page 135.
So 2.5 is what I should be using.
That's the empirical rule. That's what, and they don't have that on page
No, it says
138.
2.35.
Yeah, on
And then-
both
Yeah.
images.
Okay, well, right here, let me do this.
But-
Put a 3 right
But
here.
mathematically, that's how you get 99.7, right?
That's 100.
Okay,
You
there's
look at this like
3.
this, That's 100. So,
And that's 3.
and then
And then out here at third standard deviation is 0.15.
Right.
Okay, now some books don't do the 0.15. Some books just say 2.5. So this book, I don't care too much for, but there. That's what you should know. All right, now,
Should we use it at the 1.5 or 2.33?
whatever's in your book is what you need to use. So they should have, you said 2.35 and 1.15. Is that what's in your book? Page 238. Whatever's in your book.
138.
Okay, page 138. That's what you should be using. All right, now, it says, what percentage is between 64 and, well, you got to put, let's see, what is this? 100 and a standard deviation of 12. So this would be 112,
112.
or this would be 100. This would be 112, 124, and 36. And what's the other side?
76, 64.
76.
88, 76, and 64. That one's 88. Erase it.
Okay, well, let me start over. Thank you. 88, 76, and 64. Now, the first thing they ask, we'll use a highlighter, is between 64 and that number. And what you should do is add all those up. When you add all of them up, what do you get? 99.7 or 99.7. You get 99.75. Okay. And now the second one. What percentage has an IQ less than or greater than 136? Less than 64. So that'd be 0.15 and 0.15, which is what? 0.3. And then this one says, what percentage of people greater than 112? Well, that'd be 13 plus 2.5, which is 16. And the reason I said 2.5 is 2.35 plus 0.15 is what? 2.5, and then 13.5, that's 16.
What was my answer? Go on.
15.8.
See? My question was a little different. Sorry.
Let's see what they're asking. See, the second question, we'll use, oh, come on. The second question, we'll do in blue. The second question is asking this, and, I'm sorry, let's see, less than 64. I'm sorry, I messed up. Less than 64 and greater than 136. Well, that's 0.15 and 0.15. And then the last question we'll do in green is asking this, greater than 112. So greater than 112 would be this green area right here. And if you add all those up, you're going to get 16%.
All right, I got all that. Go to the next one.
Yes, ma'am. Glad nobody else had any questions.
Well, if I have it, no.
Okay, well, okay, all right, I'm sorry.
For sure, the dumbest one in here.
Give yourself credit. All right, that's number 14, so the next one is number 16.
Oh, shit. See,
See? What?
what?
This says, the following data is blah, 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 blah. Find the 5-number summary. So spreadsheet, not that you have to do it on spreadsheet, but I'm going to do it because that way you can see everything.
That sounds fun.
So first I'm going to make it bigger. All right, there's my numbers. First thing I'm going to do is what? Put them in what? Put them in order. So you highlight them and you go to data and hit the A to Z. They're in order. Now the 5-number summary is men. First quartile.
Is it just 0.6?
What?
Nothing. Go ahead.
I hadn't done anything yet. The men, the first, the second. The second is also called the what? Median. The third, and the max. I'll do the men and the max for you. That's that number. And the max is this number. Okay, the median. Well, how many numbers we got? 1, 2, 3, 4. We'll just count 1 to 13. So that means number 7 is our median. Now that's the median. How many numbers are above the median? 1, 2, 3, 4, 5, 6. So these two got to be averaged together. Equals parentheses this number plus this number divided by 2.
I mean, how'd you get 605 again?
Add these two, get the average of these two numbers.
Because it's the middle of the count.
And then these two numbers.
So if there's an even, if the numbers are even, like in your A column,
Mm-hmm.
your median would be the average of the two middle.
Yeah. Equals, excuse me, parentheses, this number plus this number divided by 2. And there is your 5-number summary. Now, what accompanies a 5-number summary? Box plot, Hubert. That's right, class. So what goes at the bottom? The men. So I'm going to put the men right here. That goes, that's the midpoint. We haven't figured the midpoint, so let me figure the midpoint right quick. The midpoint is equal to the min plus the max divided by what? 2. That's our, I'm thinking. And max. That's great. I'm trying to do this for y'all, so don't fuss about me. And that's green. All right, now what do we need here? We need midpoint of these two numbers. So parentheses, this guy plus this guy divided by 2. And I need the same thing here. This guy plus this guy divided by 2. Now you can do this in your head, but decimals is hard. So this guy plus this guy divided by 2. This guy plus this guy divided by 2. This guy plus this guy divided by 2. This guy. And there's your number line. So now you got to plot your what? The thing that you plot for your box is right here. So I take my handy dandy blue pen and I put 0.601. 0.601 is about right here. Y'all agree? I don't like that. Hold on a second. Oh, I'm hitting the wrong undo. Duh. There. All right. Let me get my straight line maker. I want to make a big mark, and I want to color it blue. And that's going to be right here. And then the orange is 0.609. 0.609 is right about there. Trying to make it straight. Take my handy dandy black line maker, make it thin. Connect these guys. And then what goes in the middle? The yellow. 0.605, and look over there. Now what does that tell us?
It's about even.
That it is a normal what? It's pretty much a normal what? Distribution, Hubert. That's right, class. Because everything lines up. You got an equal amount on this side, you got an equal amount on this side, and that yellow mark lines up above the what? Midpoint. The data is valid, and you have a normal distribution. Now let's see what the question asks. I have no idea what it asks. Let's see. Which one is it not? Well, it's not this one, and it's not this one. So it's A, and it is roughly what? Symmetrical.
I did all that right, I don't know why I put that 16.
That's 16. 17. Okay, here's where you're talking about using F4. So write this one down because this is test scores. So I'm going to go to the Excel spreadsheet and I'll blow them up. Now these numbers are called X. If you add all the X's up, what do you get? You get N. I'm sorry, if N is equal to 5. That's how many there are. Ugh, had a brain bubble there for a minute. Okay, there's 5 test scores. First thing you do is put them what? In order. Now, what do they want? Well, they're going to want the mean. They're going to want the median. They're going to want the mode, range, mid-range, which is the midpoint, variance, and standard deviation. First thing we need to find is the mean, because mean is X bar. So I'm going to go out here beside the mean, and I'm going to put parentheses X bar. And that's equal to the summation of what? X over what? Over N. Summation of X over 5. There's your X bar. Median is the middle. Mode, NA, or none, or does not exist, do not put 0. Range is equal to the highest minus the what? Lowest. Mid-range is equal to parentheses, the highest plus the lowest divided by, now we got to do the variance. Excuse me. The formula for the variance of test scores is equal to the summation of X minus X bar quantity squared over what? N. That's the variance. And of course, the standard deviation is the square root of the variance. So, we got to take X minus X bar. Read the directions. X minus X bar. So I need to go over here and add a column. And we need to call it what? X minus X bar, Hubert. That's right, class. So I take 6 and I subtract what? 12.6. And if you use the Excel spreadsheet, at this point you hit F4 and enter. And then you copy that down. That's the only place that you hit F4.
After I put the formula in?
After you do the first one, when you hit that, when you click on to mean, right there, and you're fixing to hit enter, you hit F4, then you hit enter. And then you copy it down. Now let's read the directions. We've done x minus x bar, but what are we supposed to do with x minus x bar? Square it. So this is going to be parentheses x minus x bar power. So I take this guy and raise it to the what? And all that does is turn everything what? Positive. Now let's read the directions. We've got x minus x bar. We squared x minus x bar. Now what do we need to do? Add it up. No, add it up. And this is your numerator of your function, of your velocity formula. So v is equal to 129.2 divided by 5. It's n minus 1, sorry, which is 4. There you go. So somebody do that on your calculator, and I will do it on my handy dandy do-jigger up here. And that's going to give me my variance right here is equal to this number divided by 4. I got 32.3. And then what is the standard deviation? That number raised to the what? 0.5 power. And that's that. So 5.7 and 12.6. 5.7. Oh, they want the variance. Okay. And 32.3. What was ours? Probably right, but 32.3. Is that what they're wanting?
Go over the standard deviation one more time.
The standard deviation is always the variance raised to the what? 0.5 power, or take the square root of the variance. That's the same thing. All right, how does that make you feel? Make you feel a little bit better?
Yeah.
So everybody can go make 100 down. When's the test due?
What's the homework due? Not the same day the test is due.
No, I'll cut it off next time on the day of the test. This time I gave you the weekend, but I'll cut it off the day of the test next time.
Will you give us some warning when you're going to post the test this time?
Yeah, I'll give it to you.
Thanks.
So that way y'all can still wait till the last minute. That's what y'all want to do, right? All right, now today we're going to start our handy dandy probability section.
You know how on the test we had like 3 or 4 questions that were like not really about
My handouts,
yeah, it was the handouts. Will we have that many on each test, or is that just the first?
you have it on each test. Unless somebody complains about it. I don't know. You just okay. What is probability? Y'all ever got on Wild Hog Road before? Highway 187 going to Pendleton? It's a 2-lane road about 6 to 8 miles. Crosses 85 and goes to Pendleton. It's a shortcut instead of going Clemson Boulevard. Anyway, you go get on Pendleton, 187 going to Pendleton, and you get behind a little old blue-haired lady. And she's going how fast? No, she's going 30, buddy. If you get on Wild Hog Road, they're going 30.
Is it called Wild Hog Road?
Yeah. It's called, the state name is Highway 187. But there's two Highway 187s. There's South Highway 187, which is like 5 miles from Highway 187 going to Pendleton. But it's called Highway 187. So anyway, Highway 187 north that goes to Pendleton is called Wild Hog Road. Anyway, when you get on Wild Hog Road, if you get on it at 8 o'clock in the morning and you got an 8 o'clock class, if you get on it at 15 till 8, you're going to get behind the little old lady. And she's going to be going 35 miles an hour. Now, why has this got anything to do with probability? Well, by the time you get to the end of Wild Hog Road, you can either go to the right or you can go to the left. Right goes to Sandy Springs, left goes to Pendleton. When you get behind that lady and you get right at Pendleton High School and you're about 500 feet away from the red light, you start to say to yourself, please don't turn left, please don't turn left, please don't turn left. And what does the little old lady do? Turns on that left turn signal. How did you know that was going to happen? Well, that's basically what probability is. How many times have you gotten behind the little old lady's driver's club? Whenever you're in a hurry, that's when you're going to get behind them. And no matter where you're going, when you get to a red light that either turns left or right, that person is going to be going the same way you're going to hold you up even more. And you've done this before. You've actually been behind somebody and you say to yourself, you know, this person is going to turn the same direction I'm going. And boom, right when you get to the red light, they turn on the signal that you're fixing to go. That's called probability. What have you done? Can you see into the future? No. You take the times that you've gotten behind the little old lady and you think about that and you say, you know what, I got a 50-50 shot. She's going to turn the same way I'm going. And it usually happens that way. You've taken mathematical experiences or experiences that you've had in the past and you've got it in your head and you put a prediction on an event. And that is what probability is. So if you're going to write a definition for probability, then the definition, the Hubertism definition, is going to be assigning a number. Probability is assigning, that don't look right. Assigning a number to a prediction. That's it. The number is going to be between, I'm trying to work here, number, sign, the number is going to be between 0 and what? 1. Now, you didn't put a number prediction on your guess that the lady was going to turn left. No, you just said to yourself, I bet you $1 or I bet you everything she's going to turn left. In other words, your probability of that lady in front of you turning left the same way that you're going is 1 or 100%. You have no doubt. How many of you have done that before? Gotten behind somebody and you can say, that woman's going to turn left. It happens. Happens with cattle too. When you get up cows, let's say you get up cows, you have a 40-acre pasture, you want to get them into a 5-acre pasture, and the 5-acre pasture, you get them into a holding pen. If you have 2 or 3 gates on the 10-acre pasture or the 5-acre pasture, and you open one to let the cows in, and you got the gate open to the holding pen, and you got the gate that you didn't lock on the other side of the 5 acres, which one are they going to head toward? Are they going to head toward the holding pen? Hell no. They're going to head to the gate that you didn't leave, that you didn't close. And it will happen every single time. Now, does that mean that I am a fortune teller and that I can tell the future? No, nobody can tell the future. If they can, what's the first question you ask them? Huh? No. If they could tell, if you meet somebody that I can tell the future. What do you ask them?
Lottery ticket number.
What's the lottery ticket number for Wednesday? First thing you ask them. And if they give you a BS answer, then you just write them off because they can't tell you. Usually people like that start a question with what? A question. And they get you to tell them what you need to know. All right? I actually know somebody who thinks they can interpret dreams. You ever met anybody like that? You're what? Now, is she right? Most of the time.
Right, there's books, it's a science. Like really, like there's like.
Yeah, but who creates the dream? You do. You see what I'm saying? I think it's a little bit.
But it's kind of like a probability because they take a bunch of people's dreams that are the same,
Mm-hmm.
and then the outcome. You know what I mean? So like,
Well, I need to know what my dream. I have a reoccurring dream,
what is it?
and that dream is me. I'm at Clemson, and I'm taking an English Clemson. Clemson University. You can't say Clemson because if you say Clemson, you're a racist, ignorant Southerner.
No king in it.
Yeah, you have to say Clemson. You never watch ESPN? You ever watch it when they have a Clemson game in football? They say Clemson. They don't say
I've
Clemson.
never heard anyone say Clemson.
You wait till you listen to
I've never heard
ESPN.
I watch ESPN all the
Okay,
time.
who's seen that? Okay, I'm not crazy. There's one person in here that's seen it. But they will. They say Clemson.
But the probability of you being crazy is still out.
Okay, all right. Well, I appreciate that. But the whole point is, I have this recurring dream. I've had this dream about 10 times. And it's a dream of me being in a English class at Clemson. And I just quit going. And then I try to do all the assignments at the last 2 or 3 days, and she's already dropped me, and that's when the dream ends. So you tell me why I keep having that reoccurring dream, and I've graduated since 1995, so I don't know why I keep having that dream.
They say if you have a recurring dream or your teacher falling out, it's just like your organization of sexual repression.
Sexual what?
Repression.
Repression.
I guess that would be.
Okay.
Yeah, that's the.
You keep having a reoccurring dream of what?
Like, I'll be in class and they look down and they
Okay, well, y'all need to find out, somebody needs to find out why I keep having a dream of missing English class. So, anyway,
Was it Mr. Deluxe?
Mr. Who?
Jim Deluxe.
I don't know. I don't even know who the teacher is. But anyway, I don't know about the predicting dreams because the reason I have a problem with predicting dreams is not the person that's predicting it, but I have a problem with the person you're creating the dream. So if you're creating the dream, seems like to me you would know what it means. See what I'm saying?
How about I had a dream that my friend at work was having a baby girl and like showed me the sonogram pictures, the ultrasound pictures, and like the lines were showing that it was a girl and everything. And I told my friend Sabrina, I said, look, I just had this dream that Bethany's having a little girl. I said, and she was showing me the ultrasound pictures, and the ultrasound pictures actually had lines on it showing that it was a little girl and everything. And how about Bethany came to work? I had told her that I had.
And you had a deja vu moment.
And she showed me her ultrasound pictures that she was having a girl. I bet everybody that she was having a girl.
Did she?
Nobody believed me.
Did she?
Yeah. And she brought in the ultrasound pictures and it had the little lines exactly where I told my friend Sabrina that they were.
Now that I don't have a problem with because that could, you could manifest that. I mean, you could because there's a 50-50 shot.
Right, sure.
And I could.
But what about the ultrasound picture? What about like the picture with it?
I don't know.
Exactly
I don't know
like
how
the lines
you could
were
do
on
that.
and everything.
I don't know.
Yeah.
Yeah,
There's no telling.
scientists say that you use more of your brain when you're sleeping. So like some people actually believe like when you're actually dreaming, you're really alive, like you're more awake.
The brain is working more. Well, I just have a problem with somebody, if you dream about a purple cat and he's up in a tree and it dies by hanging itself, that means that your brother-in-law's sister is going to hang themselves. I don't think you can.
I heard that whatever happens in your dreams, that's what you secretly want to happen.
There's no way that's true though, because there's some dreams that I have and I'm like,
Well, that's what I'm saying. I just don't.
Okay, how about this one? I had a dream that my husband and I were house hunting. We've been house hunting for like a year and a half.
This is probability, okay?
Okay.
Because somebody's going to complain about it. But anyway.
I had a dream that we had bought a yellow house. Well, we went and looked at the yellow house, and we didn't buy that one. And we were looking for houses, and then all of a sudden my husband saw this house for sale, and it was like way out of our price range. And we were like, well, we'll just look at it anyway. So we went and viewed it. We walked into this house. Every single room in this house was wallpapered yellow. I mean, not just yellow, bright yellow, 1970s flowers in every room. And we ended up buying it.
Oh.
Now, that could have been because you saw the yellow house and you didn't buy the yellow
Yeah.
house.
This is a two-story brick house that was way out of my price range.
Wow.
And I wrote them a letter.
Look, see, she's leaving. She's going to go tell it. She's going to complain. See ya.
So dreams can mean something.
I know. I just have a hard time with somebody taking a dream and telling.
Yeah, I'm not saying I can translate them. I'm just saying.
Yeah, that to me is just.
Have you ever heard that you can like control your dreams?
Yeah, you
I
can.
heard you get like experience.
It's called dream building. Like,
Yeah.
there's books on it and stuff. Like, you
Yeah,
take
Supposedly, like to get there, every time you have a dream, you have to wake up in the morning and write down in like a journal. And then
I've got a
after
friend that
so
does
long,
that.
Really? Apparently, after you do that for so long, you get where like you can
create
control your dreams.
someone.
Yeah.
Like, if you could do that, that'd be pretty awesome.
I definitely
It's not
I
really
used to not be able to fly.
It's pretty easy when you try.
Now you can fly.
Yeah.
Well, I want to get finished with that English class. Somebody tell me how to get finished with that freaking English class. Oh! Gosh. All right. So decimals between 0 and 1. Now, the biggest thing with probability is that you read the question and you know what the question's asking. If I was to ask you, what is the probability? And this is the way you write probability with a big P in parentheses. The probability of a king in a deck of cards. Well, the king in a deck of cards, how many kings are there? Well, see, you have to know what the deck of cards is. You have to know how many is in a deck. You have to know how many are face cards. You have to know how many suits there are. So the problem with a lot of questions in probability is not the math, but actually knowing what the problem is asking for. So the probability of a king would be 4 out of 52 because there's 4 kings in a deck of 52 cards. And that comes out to be 1 over 13, right? Which is equal to some decimal. And that decimal is your probability. All right? Now, what if I asked you for the probability of an even card? And face cards are even. Well, I would have to put that stipulation in the question, and aces are not even. Aces is 1 or 11. So then you would go, okay, 2, 4, 6, 8, 10, 12, king, queen, jack. That's 8. So that would be 8 or 9. 9? Let's do that again. 2, 4, 6, 8, 10, 12, ace, king, queen. No, king, queen, jack. That's 9.
It's 12. There's not a 12 card.
Yeah, there is. Where is the 10?
It's just 10.
I'm sorry. 2, 4, 6, 8, 10. Thank you. I don't know what I was thinking of. Oh, I was thinking of dice. All right. 2, 4, 6, 8, 10. And then the queen, king, and jack. All right?
Right.
So there's 8.
8.
And that would be 8 times what? How many suits are there? 4. So 32 over 52. Now see again, the math is very basic. You punch it in a calculator. But to get that 32 right there, you have to what?
How did you
Think.
get the 32?
Huh?
How did you get the 32?
Well, we said there's 8 cards that are
Oh,
even,
8.
and there's 4 suits.
Gotcha.
4 times. So you have to what? You have to read, and you have to what? Think. What if I ask you for the probability of a 7 on a die?
On a singular?
On a single die. 0%.
Unless the dice have,
Unless it's fixed.
right, like some dice have.
Yeah, 8 or 9 sides, yeah. This is a regular 6-sided die. If I asked you the probability of 7, you would say 0%. Okay? Or what is the probability of your birthday falling on the 8th day of the week? 0. Why? There's only 7 days. What is the probability of you working 56 hours? 0. Although there are some people that work 56 hours in a day. What's the problem with working 56 hours in a day? Oh, I'm sorry. What is the probability of working 56 hours in a day? 0. But sometimes you meet people, but those are the same people that you don't ask how they're doing. They work 56 hours in a 40-hour day. I used to have a student like that. I used to tell them to quit. That's where that whole quit loser thing comes from. Every day they'd come in. How are you doing? I made that mistake one time. And I didn't ask them how they were doing ever again. Oh my God. Might as well just shoot yourself. So, what is probability? Probability is equal to an event happening over the possible number of events happening. Okay, so the number of events happening over the possibility. So if I asked you what is the probability of tails on a coin, that would be what? 1 out of 2, which is 0.5. Now, again, the problem with probability does not come with these type questions. All right? The problem with probability comes when you read complex questions and you put the additive law with the multiplicative law and the counting using factorial. So this section right here is kind of a gimme section. I don't know what chapter we're in. Somebody look, but I think it's 4.1 or 5. In the old book, it was 4.1, chapter 4. So this is chapter 5.
Chapter 5?
Mm-hmm. So this is probably 5.1. I don't cover chapter 4 very much. Chapter 4 is on regression. Let me make a note. Chapter 4 is on regression. What do I want you to do with regression? What do I want you to do with regression? I got to look up repression. She said repression. I got to look that up. But anyway, regression, sorry. Regression is basically a scatter plot. Let me just give you an example. And this is chapter 4, and this is all I'm going to do on chapter 4 because I don't test very much on chapter 4 in
We
this
have
book.
chapter 4 homework?
You'll have some, yes. But I won't test you very much on chapter 4. Let's say you have a bunch of dots. Represents points. Let's say this is number of widgets made and the cost of the widget or whatever. Or let's do this. Let's say I'm thinking of something. Well, I'm not going to think of anything right now. I can't think of it's kind of like when somebody asks you the name of the song while it's playing. Anyway, put a line through here. That's called least square regression right there.
What is it,
Least square regression. In other words, a perfect fit of a line with a bunch of data points. All right, what do you see with those data points there? Do you see an upward slope or do you see a downward slope?
Upward.
It's a positive correlation. All right, so that's a positive correlation. And if they ask you to find the slope in the equation of that line, you go back to your find a point here, find a point here, find a point here, calculate the slope, and find the equation. Now, you've done that in pre-algebra and Math 101, which is a prerequisite to this. I'll give you the two formulas. Slope is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's how you find the slope. If you get a positive number, that means it's going left to right what? Up. How do you tell? Which way do we read? Left to right. So put your little car right here. And what's that car doing? It's going uphill. Uphill is positive slope. Positive slope, positive correlation. Okay? The point slope equation, y minus y sub 1 is equal to m times x minus x sub 1. So let's say that you draw a line in these least squares, this scatter plot, and you draw a line and you got 2 points. Here's one, let's say this is 60 and 60. Hold on a second. We're going to do this just because this is all I want you to be able to do with regression. 60 and 60. And this is 10 and 10. Okay, so you got a bunch of dots. You draw a line that's in the middle that pretty much goes, and then you find 2 points on that line. Then you plug and chug. 60 minus 10 is what? 50. And then 60 minus 10 is what? So what is the slope of this line? What? 1. Now you pick a point. Which one point you think I'm going to pick? 10 or 60 or 60? 10 and 10, because I don't like to use big numbers. That does not keep it simple. Plug it in. Y minus 10, it's supposed to be y sub 1, is equal to, oh no, yeah, equal to 1 times x minus 10. Y minus 10 is equal to x minus 10, and I'm sorry, I'm thinking of the next step. And basically, y is equal to what? X. So the equation of your black line here is y is equal to x. All right, that's one example. Here's another example. What if I give you this?
No correlation.
No correlation. What is the slope?
Nothing.
0. Why? Well, draw a line between them. If you start on the left, you can't draw it up there because that's not, you can't draw it down here because, so where's it going to be? It's going to be right in there. And if you pick 2 points, you're going to get a slope of 0, which means no correlation. And of course, what do you think the last one's going to be?
Negative.
Negative correlation. Oh, well. And look over there. Negative correlation. So take a look at chapter 4, but I'll be glad to go over any questions you send me. But most of the time they're going to ask you if it's a positive correlation, a negative correlation, or a constant correlation, meaning zero. I meant not constant, but zero correlation. Or they're going to ask you to find the slope and the what? Equation. All right, by y'all movements, I'm thinking that y'all are as close to time. I don't know what time it is. What time's class over? No, it's not over at 2:10. I thought so.
This week, 2:15.
We're not ready to go yet, but I will call it a day since y'all want to leave early. Let's turn this off first. Hold on. Then I'll get the roll. I don't know what I'm doing. There it is.